Howdy folks, this is a project that I've been working on for a few months. This is the parts for a Razor Crest Control Lever. So you might recognize this little ball as the ball that Grogu or Baby Yoda was always kind of taking off of the ship on the Mandalorian. And this is something that quite a few people have been replicating. I didn't make this, I bought this. This is made by Custom 3D Stuff. He's a user on the Replica Prop forum. The model is called It's Not a Toy, and it's his 1.5-inch model. So this is actually pretty well made. It's a nice aluminum piece. It's got M16 thread all the way down, and then a anodized aluminum cap. The blue marker in here kind of wears off, and I'll replace that, but I might not. I kind of like aged looks on my stuff. It does require using a threaded adapter to fit to this 1/2-inch rod that I have. This is pretty accurate to the movie. These are kind of expensive. You have to only can basically buy them in a set, and they're made for cars. But this little guy I 3D printed, and so he's an actual thread adapter. So the design for this is open source with a basically license out there for non-commercial use, and hope that people will kind of build this. Don't know if I'm ever going to do a group buy on these. I've worked out what the cost might be, and that's actually in the spreadsheet on the shared files. But for now, I wanted this for myself. So in either case, I wasn't actually too interested in just having the ball until I ran across a thread by E. Williams on the Replica Prop forum, where he took a rod. He actually made his own from just a ball I got off McMaster. He added a rod, and he did a 3D printed body that was similar to this, and put magnets in it, mounted it to the wall, and it was just this piece like this, mounted it to his fridge. But that kind of sparked the idea. I wanted it to look a little more like the movie, where it had the base. And then because I'm me, I'm actually making it functional. So there is a Trinket Micro, or Trinket M0, sorry, and a potentiometer that'll get wired up, and this will actually show up as a USB joystick. Now you're only going to have one axis, the throttle axis, so it's going to act like a little throttle. And you can use that in Star Wars Squadrons. I might show that a little bit later. And then these parts, I've designed all of this in CAD. I've actually gone through quite a few revisions and prototypes. I can show some of those if I need to. In order to get this designed so that it's very functional for everyone and for myself, this is just the way I work. So all of these plates here, these are from Send Cut Send. They're stainless steel plates. In total, only cost about $30. But what they do is add ballast, so that this thing's a big lever hanging off either side, so they actually add weight, and so that when you tilt this sitting on a desk, it won't fall over due to the nice heavy pieces here. And then not having a brass piece, having a 3D printer piece saves a few ounces there. All right. The rest of the hardware here is from McMaster. Now these 3D printed parts, which are all these gray pieces here, these are 3D printed on a Form Fuse 1. I have access to one of these now, and able to print some of my own parts. They come out incredible. This is raw off the printer, and you can barely, maybe right there, under just the right lighting conditions, you can maybe see some layer lines. Otherwise, it comes out absolutely incredibly beautiful and accurate. Down to, printing these little tiny gears. Because I'm using 3D printed, I can print helical gears that mesh better than regular. And I can print this as a single integrated piece. And then this is the base plate. So it's got a spot to hold the potentiometer, to hold the trinket. It's got a spot for a ball detent, this little tiny thing here, and that provides a center stop. And then a spot for a speed limiter. So I, at one point, took this guy out of the design and added him back in. The speed limiter, I was hoping would add a little more friction, and it does. But the biggest thing it does is keeps it from kind of drooping and falling over. but it doesn't add too much resistance and friction because you got a big lever right here. And then the potentiometer is just something off DigiKey. This is a really cool potentiometer. I'm using them in my Pip-Boy design. They're 360 turn potentiometers, so you don't have a stop. So you can actually kind of use them as rotary encoders also. In this case, we are just using it as a traditional potentiometer, but it's extremely tiny and thin, which is great. All right. So one of the things, let's kind of get started. I might jump around a little bit depending on which kind of aspect we're working on. So this is going to be kind of a build video, but I kind of like to do these all at once as much as possible with minimal editing. It's just kind of my style. So the first thing I'm going to have to do is tap this plate. So let's go ahead and move all of our nicely knolled hardware out of the way. So both of these plates are going to get tapped. So I made it so that, one, the pieces actually get held in, but I also made this so that if you wanted to, you could put this on a hard surface and then put bolts up through it if you wanted to have this really hard mounted to a surface. Let's see here. So if there's anybody making a Razor Crest replica cockpit, you could use that. I do not have a tap wrench with me. I just went and got this tap at Home Depot. It's actually one of the things I'm really kind of short on is only a few taps. But all you need is something to turn it. And I need to find my oil. There it is. Alright, so let's see here. I gotta remember which holes I'm actually tapping. And then I think these guys right here. That's a number 832 tap. But this is stainless steel, so hopefully this tap's going to hold up to doing that.
A few moments later.
Well, I'll come back later when I get a proper titanium nitride coated tap. That's made for stainless steel. That might take a little bit.
2 hours later.
Okay, we're back. So I had to go off to work to use some better taps. They actually weren't titanium nitride coated, they were just Irwin brand, but they didn't break this time. Alright. See if I can figure out what I'm doing again. So this plate here goes into the base, and this just adds some weight, but it also provides the anchor points so that if you want to mount this to a table, you can mount that. These other big holes here, those are if you want to add some magnets like this. Now the magnets actually won't stick to the stainless steel, so you would have to super glue them in. But that'll provide a way to stick this to a metal plate, which is actually what I might be doing later, without having to permanently mount it, but still have a nice strong connection. That magnet idea, of course, came from E. Williams. Alright, so next up, let's put some rubber feet on this. So then that way it's kind of stood off the surface. I'm using some screw-on rubber feet. I hate stick-on rubber feet. There's absolutely no sense in using the adhesive rubber feet when you don't have to. These are the same rubber feet that I use on my Jedi training remote stand. That's made for Troop Defense. There's a video for that on my channel. And making a 4th run of those stands right now. I'm not sure if I'll do a 5th run yet. Alright, nice rubber feet. That way that doesn't move around on you. Alright, so next up is going to be the speed limiter. Actually, no, that goes on after the metal plate. And I was using some little small screws to hold this in. The hole in the 3D print is designed to accept this size screw. I also have, I think in the BOM I actually have self-tapping screws, but it doesn't really need them for this little tiny screw. Oh, did I miss the hole? There we go. Come on. Alright. Then this little helical gear just simply press fits on. It's actually a pretty tight fit. You got to pry it to get it off. Put in the ball detent. And then the ball detent you got to kind of play with and adjust in order to get just the right feel. So it interfaces with these little bumps, little gaps, I guess I should say. There's some at the extremes, but the extremes aren't really needed. It's really just this middle one. Alright, so I made myself a diagram for how to wire this guy up. And I actually don't have any spools of wire besides one color right now, so go ahead and use these guys. Make sure the fillet goes all the way through because I'm going to be chopping off this side flush. Alright, and what I can do on a future 3D print is actually put holes below the boards, and that way that'll sit a little flush. But that's good now. I definitely made this difficult for myself, not quite thinking exactly how these wires were gonna go through. It's funny because you can do all the CAD design you want. It's a term that I just learned on, I hadn't heard before, on Stuff Made Here. We called it CAD goggles. And let's grab our little gear, make sure the mechanism still works. Yep, still free spinning. Gear is actually going to go on the other side. Actually, I could install the gear now. So this guy has got a little shoulder, this gear, that snaps in here so that he doesn't come out, but it's still free spinning. And then this gear's got an arrow, so that when this is at the neutral point, the arrow's pointed up, so that you got the most range, because all the way over there's going to be a 0 point that's going to kind of jump back and forth. So when you get it assembled, you basically want him pointed up when the shaft is pointed up. Alright, I'm going to go test, make sure that all my wiring is good before I finish with the rest of this. Alright, so in order to stop any rattling, I'm going to put some hot glue in here. I wish I would have done it before I put on all the other parts. Let's see, actually, you know what? All I need to take off is him, because I think I can get past that. So let's do that real quick. So let's put down something to stop the rattling. And this, of course, is going to cool off really quickly, and I don't want the extra thickness, so I just need to push. And then we're going to do the same thing with this top plate. Let's see if it's going to rattle. Maybe we don't need to do it with the top plate. See, the only rattling should be from the pot, and that won't rattle once the gear's meshed in. So that's good. Next up, we can start assembling this guy. But before we do that, we're actually going to line him with aluminum. So then that way, this looks like it's actually made of metal, and we want it to match that. So I've done a few test pieces already. And where'd the other one go? There we go. So these two test pieces, one was on a 3D print I made from Shapeways, and one was on one I made on an FDM 3D printer, both earlier prototypes. So both of these I did the same technique. The only difference is this one I aged using the chemical aging that I used on the Mandalorian pistol and the Beskar, and this one I used black acrylic paint. And to me, the chemical aging just has a slightly different color tone. It's not even a matter of polishing. So I am going to go ahead and do the chemical aging on my final part here. So, but I thought I'd try this time, and if it doesn't work I can always undo it, is to actually age these while they're flat. So this is just Nasha brand aluminum tape. And then one of the issues I had was while trying to age it, I was peeling off some of the edges and corners. So let's try aging it ahead of time. For this, there is going to be, since I'm working with a chemical, there's going to be a fan running, so sorry about the noise. But I want to be safe, and I'm also going to be wearing a respirator, so I'm not really going to be talking during this next part. If you want to see the chemicals I use and everything, go look at the Beskar and the Mandalorian videos that I've already done. Okay, now I'm done with the dangerous chemical portion. What we're going to do is bring this back to basically match the stainless steel as much as possible. Now the stainless steel, of course, is really bright right now. We're going to dirty it up a little bit. So what I'm really doing more is trying to get this color temperature. Aluminum has a little bit more of a blue hue than the more neutral gray of stainless steel, and this is really what a lot of this is doing. So I'm actually going to be cleaning off a lot of what I just did, but you can't seem to get it all the way back, and the result I quite like. I'm not going to take too much off yet. Oh, maybe I will. To me, that's much closer than the stock piece of aluminum tape. So there's a little comparison. So first we're going to start with the sides. Okay, what we're going to do is use a soft cloth, push this down starting from one edge. Now the nice part about the SLS materials is a little bit rough on the surface, which means air, won't get any air bubbles kind of stuck under here. And then before we curve anything over, we want to break these corners so that it doesn't want to take the curve around that corner. So then we're going to bend this corner over. We're not going to bend the top edge over, we're going to just simply cut it away. And I found it best to hold the knife still so you keep it really parallel to the table and rotate the part. You've got to be a little careful not to actually cut into the part. Come on, got a nice brand new sharp X-Acto blade. Maybe we're going to go ahead and trace the part, but this is how I cut into it last time. And then we'll go ahead and run one more cut. Make sure we're clean through, don't have any burrs. Oh, there I went and cut the part a little bit. All right. So now what we're going to do, starting from the inside edge, is rub over. Do not go in this direction at all, or even this way. You'll lift the edge. You want to get this stuck down nice and good. You also want to remove any adhesive that kind of squishes out. You just want this barely on the edge. All right, I think we're all right. Now this one's going to be a little bit trickier because you got something you want to try to keep parallel. So we'll try to lay this out. And we'll try to put this right in the middle and line this up as best we can. Then roll that way, back. And then before we do anything else, we want to make sure there's no air bubbles. Next thing we're going to do is cut right down the middle as best we can. It's going to want to tear on you. It's all right. We're not going to really see it. Although I got a little close to these corners. I meant to actually start here. Start in this corner and push at a 45. Same thing here. I can even find the corner. Oops, that didn't go to 45. Okay, now what we're going to do is roll all these in. And of course the adhesive wants to stick to everything. You won't see too much of the inside anyways. Okay, now I'm going to leave that alone for now. We're actually going to go back and try to cut these corners off. Now in this case I'm going to be a little bit, if you get it just perfect, you won't see any seam, but that's really tricky. Let's give this a try. Trying to keep that blade as close as I can to the part without cutting it. Okay. Okay, let's see if that did it. So that's pretty close to the edge. So what we'll do here is kind of squeeze these. So I'm not doing this or this. I'm actually kind of squeezing the two corners together. Sometimes I got to roll a little bit back depending on the, you'll be able to feel it. Alright, next thing is the back of the X-Acto. Being very careful to kind of just apply a little bit of a chamfer polished edge without lifting either side. A little bit of a fold over. On an earlier prototype I did actually fold the top edge over a little bit more. You can see on this side, where this is where I tried the technique I'm using now. And then this is one where I didn't do very good on getting rid of the corners, so there's a lot of little missing gaps where I tried to just kind of burnish the edge like you would a piece of leather. But now this part is a symmetrical design, where this of course isn't, so the side you want facing yourself, if you've got a better side, you can go ahead and flip it around. Alright, so back to the inside here. So all we're going to do now is go back in, and I'm using the butt of the X-Acto blade to just flatten this out. I do want these to go ahead and wrap around as much as possible so that it doesn't want to give later come undone. Alright, that's a very tedious way to metalize a piece of plastic. So it looks like maybe might need to apply a little bit of brushing. Get this to match a little bit better. We are gonna do some general kind of aging with some acrylic paint on top, so maybe I'll just wait till I do that. So the way I designed this is in order to make it so that moving the actual lever won't ever actually loosen up the center. It's basically just sitting on this kind of aluminum pivot. So all we need to do is put this in the middle, and this is where you're going to decide which side is your favorite on here, because the gear is going to end up on the right hand side. So let's see. And what we'll do is put in the gear, put it into our little cutout here, and then it just installs using some screws. Now these screws can be help adjust the tension, so you can tighten the screws and that'll squeeze kind of on this middle portion. For now we'll leave it loose. We can always tighten them up later. Just want them to be held in there. Now the shaft is held in here just via kind of a friction fit. I did that so that there wasn't anything visible holding it in. It actually holds pretty good. Alright, so this is a little bit tricky. You need to have this gear pointed up as best you can after you assemble it, but it wants to rotate as you assemble it. So you kind of got to go off about maybe 45 degrees or 30 degrees. Keep this straight, and then come straight down. And this guy rotated almost 90 degrees, so let's go a little further over. Try one more time. There we go. So he's pointed up and he's pointed up. And then you can see this has really nice mesh. So I added these just to add mass to the middle so that when you got the lever over here, this doesn't want to tilt over. So these guys kind of rotate in, and the ones that got the kind of funny cutout match up with this. So you're going to want to put this in this position, kind of think about how those go, and then they go in and they rotate in like this. Similar, we're going to go ahead and put some hot glue so that these guys don't rattle. So what happened is the hot glue already cooled, made it jump. Alright, yep, let's do some E6000. That way it has more time to set up. It will stop it from rattling, but it'll also be able to flatten out, which is the problem with the super glue. So let's give ourselves a blob in there. And another blob back here on this side. We're trying to keep the part away from the E6000. We'll push it in. There we go, that's better, because now I can push it against the surface. Let's make sure this fits. It should. It does. And then this has got a little bit of a chamfer right there that matches up with this side. So again, gotta remember, get these oriented the correct way. It only goes in one direction. So you might want to practice before you get glue all over yourself. Alright, we're going to push that down. There we go. There we go. Now the metal plates are in. Crisis averted. But I gotta redo the aluminum, so I'll be back when that's done. Okay, so let's get this lined back up. So this guy's at about almost a 90-degree angle, about 75 degrees. Hold that straight up and let this come together. You go a little less right there. There we go. Arrow in there straight up. Alright, that's looking pretty good. I think I'm going to do... Alright, well actually we'll go ahead and put the ball in. So, this is my 3D printed thread adapter. I've also used the brass one, but since this will save a little bit of weight, we'll go ahead and thread that in. Takes quite a few turns, so Grogu had to work at it to get it off. But there we go. And then, like I said, it's just a press fit. So give it a good tap. So here's the gear mechanisms inside working. So when that's vertical, that arrow's up, we're good. Now, right now it feels a little floppy. But as you can see, it won't tip over. It will, of course, if you push on it, because it's still a lever. So what we'll do, so speed limiter helps a little bit, but we'll actually compress these, and then after that we'll adjust the detent. Half turn at a time until it feels right. Because the nylon's a solid material here, you can do this without worrying too much about crushing the material. And the ball detent will help with this a little bit, so I might switch over to the ball detent in a minute. Because the ball provides some compression also. In fact, that's pretty good. So now we'll switch to tightening the ball detent. Right now I'm trying to feel for the actual ball to fall into its little slot. There we go. Let's do a little bit of painting just to kind of tie the two metals together. Should be enough here because I'm just doing a little light wash. So all I want to do is darken those corners, say around the screws and things. Of course, it's going to darken that one little edge, so we might try the chrome pen here in a minute for that one edge. The other thing I like that black acrylic paints do is they kind of leave a matte finish that, to a certain degree, kind of makes it the two metals tie in a little bit better together because they have the same kind of spectral reflection. I'm going to try to get a little bit inside, just the tiniest bit, just so there's not perfectly clean inside. Sorry if I'm off camera. Trying to look at what I'm doing at the same time. It's hard to do it sometimes through the camera. Let's go ahead and do this whole edge. That actually worked really nicely. It looks almost like a welded, little micro welded edge. Still a little bit of a color difference, of course. And if I wanted it brighter, I could just leave it there and not actually remove any of it. But okay. So here is our finished functional Razor Crest Control Lever. So it has a detent at 50%, and then won't fall over, especially if you've got some magnets on it. It does kind of lift up, so let's go ahead and install the magnets then. There we go. Okay, we got the Razor Crest Control Lever hooked up to the computer. And then, don't tell me the axis is inverted. Why is the axis inverted? I swear I tested that. That's how I got my wiring diagram. Oh, I know why the axis is inverted, and I didn't think about it. The gear inverts the direction. I tested it with the gear, twisting that gear back and forth, forgetting that it's inverted there. It's okay, I can invert it in software, no big problem. A lot of game software can do that also. So let's go ahead and calibrate this so it has maximum range. There we go. 0 to 100, nice and smooth. Little center, kind of floats to the center. That's what dead zones are for. There we go. This has been a fun project. It's been quite a challenge. Let's go try it on Star Wars Squadrons.